Good afternoon, guys. It's Thursday. I hope the test went well yesterday. We are done with chapter 4 now. We're going to move on to chapter 11. We're going to start talking about sequences and series. So this first section is really just kind of some of the basics about just some general sequences. And then in the following sections, we'll start looking at some more specific type of sequences and series. So just kind of talk about a quick sequence. It's a function whose domain is the set of positive integers. So basically, it's just going to be a list of numbers that have a specific pattern to it. All right, if we kind of scroll down here, this list of numbers represents a certain number of terms. So in this example right here, these are the first 4 terms of this sequence. All right, so this first number we're going to call a sub 1, which represents the first term. The second one we're going to call a sub 2, which is your second term, and then a sub 3, your third term, etc., etc., etc. All right, so these particular values, or these numbers, have a particular pattern to them which make them a sequence. All right, so once again, so first term, we got our second term, third term, fourth term, etc., etc. All right, so these lists of numbers represent a set of terms. All right, so this first example right here, we want to write down the first 6 terms of the sequence. So I want a sub 1, I want a sub 2, a sub 3, a sub 4, a sub 5, a sub 6. Those are my first 6 terms. All right, now this n right up here, that represents the specific term you're looking for. All right, so for example, if I want to find my first term, then in place of all of my n values, I'm going to plug in a 1, because my n value is 1 since it's my first term. All right, so to find my first term, a sub 1, it's going to be 1 minus 1 over, and then my denominator is my n, which again is 1. So 1 minus 1 is 0. 0 divided by 1 is just going to be 0. So my first term of this particular sequence is 0. All right, so let's try and find my second term. To find my second term, that means my n value is 2. It's a sub 2. All right, so that means in place of all my n's, I'm going to plug in a 2. So 2 minus 1 over 2. 2 minus 1 is 1, so I'm left with 1/2. All right, so my second term here is 1/2. All right, now my third term. What am I going to plug into my n value? Very good. I'm going to plug in a 3. All right, so we plug in a 3. So 3 minus 1 over 3. 3 minus 1 is 2. So I'm left with 2/3. So my third term is going to be 2/3. All right, so let's look at my fourth term. And we won't plug this value in. We'll just kind of go through and so. So in my fourth term, I'm going to plug in a 4 because it's my fourth term. So I'm going to plug in 4 minus 1, which is going to be 3. And then my n value denominator is 4. So it's just going to be 3/4. All right, so let's look at my fifth and my sixth term real quick. All right, so to find my fifth term, I plug in a 5. So it's going to be 5 minus 1 over 5. Well, 5 minus 1 is 4 over 5. All right, and my last term here is going to be a sub 6, which means we're going to plug in 6 into my n value. All right, so I'm going to have 6 minus 1 over 6. Well, 6 minus 1 is 5 over 6. So there you go. So my first 6 terms, if we're to write them out, are 0, 1/2, 2/3, 3/4. Oops, that shouldn't be an equal sign. 4/5, and then 5/6. So those will be my first 6 terms of that sequence. All right, so to figure out what term each one is, you just take that term value and plug it in. So if I'm looking for my 12th term, I would plug in a 12 here. All right, so whatever term you're looking for, that's what you're going to plug into your n value. All right, so that's just a very basic sequence. All right, so what I want you guys to try and do, this one's going to be a little more difficult, a little more involved. I want you guys to try and find the first 6 terms here. So I'll take a quick second and do that. All right, so if you guys need a little more time, just go ahead and pause it and kind of finish up. All right, so I want to find the first 6 terms. We'll find the first 3 just so you guys can get the gist of it. Then we'll go ahead and move on to the next one. All right, so here we have b sub n, same thing as a sub n. All right, but I want to find my first 6 terms. So if I want to find my first term, all right, so that's going to be b sub 1. Again, 1 because I'm looking for my first term. All right, so I'm going to have here -1 raised to the n plus 1. All right, well, my n value here is 1, so we're going to raise it to the 1 plus 1 times 2 over my n value, which because it's my first term, I'm going to plug in a 1. All right, so here we go. We've got negative 1 raised to the 1 plus 1 is 2. So let's just kind of write this out. So I've got negative 1 squared times 2 divided by 1 is 2. So negative 1 squared is 1. 1 times 2 is 2. So my first term here is going to be 2. All right, well, let's try and find my second term. All right, so to find my second term, in place of all of my n values, I'm going to plug in a 2. All right, so I'm going to have negative 1 raised to the 2 plus 1. All that times 2 over, now my n value is 2, so 2 over 2. All right, so I've got 2 plus 1, which is going to be 3, so I'm going to have negative 1 cubed, and you have to forgive the handwriting because I'm using a mouse. So negative 1 cubed times 2 divided by 2 is just 1. So that's going to be negative 1 times 1, which is just going to be negative 1. Cool. All right, let's find my third term real quick, and then we'll be done with this one. We won't go any further. All right, we're supposed to find the first 6, but that's okay. All right, so third term. That means everywhere I see an n value, so there and there, I'm going to plug in a 3 to find my third term. All right, so I have negative 1 raised to the 3 plus 1 all over 2 thirds. All right, so 3 plus 1 is going to give me 4. So this is going to be negative 1 to the 4th power times 2 over 3 is just 2 thirds. All right, so negative 1 to the 4th. Anytime you take a negative value, raise it to an even power, it's going to become positive. So this is going to become positive 1 times 2 thirds. Well, 2 thirds times 1 is just going to give me 2 thirds. All right, and then dot, 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 dot. We can keep going. We can find the 4th term, the 5th term, the 6th term, etc., etc., etc. All right, so that's just how we're going to be finding our specific terms. So now let's take an example and look at a specific sequence and see if we can't derive what that particular pattern is going to be. All right, so determining a sequence from a pattern. Now, there are all kinds of different patterns that you can see. All right, the main ones that we're going to look at in the next few sections, one is called an arithmetic sequence, which just means you are adding or subtracting the exact same value every single time. So in this particular case, this would be an arithmetic sequence. All right, because in order to get from 1 to 3, I would need to add 2. To get from 3 to 5, I would need to add 2. To get from 5 to 7, I would need to add 2. So because I'm adding the same value each time, this would be considered an arithmetic sequence. So if we write that up here real quick, just to kind of give you guys a heads up when you guys see it. Ooh, this is an arithmetic sequence. We'll make that a bit smaller, just not taking up so much room. There we go. So this would be considered an arithmetic sequence. All right. So again, that just means you're adding or subtracting the same number each time. Now, when you have an arithmetic sequence, that means your pattern or your equation that you would use to find a particular term is going to look like a linear equation. All right. Now, in this case, whatever you are adding or subtracting is going to be your slope. All right. So if we just kind of remind ourselves real quick. So the equation of a line is y equals mx plus b. All right, and remember your m is your slope. In this case, my m is going to be whatever value I'm using to add or subtract each time. So in this case, I'm adding a 2 each time. All right, so that's going to be what I'm going to call my slope or my common difference. So my m value here is 2, again, because I'm adding 2 each time. If I was adding 11, this would be 11x, but instead, this because I'm adding 2 each time, this is a 2x. Now, I still need to figure out what my b is, or my y-intercept. All right, and this is going to be the number that I add or subtract to get my first term. So the way that I like to do this is first let's find my slope, or my common difference. In this case, it's 2, because I'm adding 2. Then let's plug in a 1 for my first term and see what I need to add or subtract out here to actually get my first term in this case, which is 1. All right, so if I were going to find my first term, all right, I would plug in a 1. All right, we're going to change this to a sub n equals 2n. All right, so let's just see, because sometimes it's just 2n. All right, so let's plug in a 1 for my first term. It should be a 1, but let's see what I get when I plug in a 1. So if I plug in a 1, I'll do this out here. So a sub 1 is 2 times 1, which is 2. All right, so if this were my particular pattern in my equation, 2 times 1 is 2, but that's not 1. All right, my first term has to be a 1. That is not a 1. All right, so what would I need to add or subtract to that value to make it be a 1? I would need to subtract 1 from that value to get that first term. So now let's see what we get. All right, so if I want to find my first term, it'd be 2 times 1 minus 1. So 2 times 1 is 2. 2 minus 1 is 1. There we go. 1 should be my first term. So in this case, it's not just 2n. So I plug in a first term to see what I would need to add or subtract to get my first term. All right, so I plugged in a 1. 2 times 1 is just 1, or it's just 2, which I need to get a 1. So in order to get a 1, I need to subtract a 1 from 2. All right, so let's just make sure this is going to fit. So a sub 2, my second term, should be 2 times 2 minus 1. Well, 2 times 2 is 4. 4 minus 1 is 3. Well, my second term should be 3. All right, let's just try one more. Let's make sure. So my third term should be 5. So I have 2 times 3 is 6. 6 minus 1 is 5. All right, so that's going to be what my particular pattern is. Or I'm going to ask for the pattern, then you're just looking for your equation. All right, now the second one's a little bit more difficult. All right, a little more involved. All right, so in this particular case, I'm not adding or subtracting the same thing each time. Notice I'm adding 3, then I'm adding 5, then 7, then 9. So I'm not adding the same value each time. So this particular one is not arithmetic. All right. Now, the other one we're going to be looking at is called a geometric sequence, which means you're multiplying by the same value each time. All right. In this case, it's not going to be that. It's not geometric. All right, so let's look to see. Now, sometimes it's helpful to go ahead and write out, okay, this is my first term, this is my second term, this is my third term, my fourth term, my fifth term, etc., etc., etc. All right, so sometimes it's just helpful to look at those particular term values to help determine what can I do with those to get a 1. What can I do with the a sub 2 to get a 4, a sub 3 to get a 9, a sub 4 to get a 16, etc., etc. And in this case, some of you may have seen it, some maybe not have. All right. In this case, to find my first term, well, let's just look at it. What's 1 squared? Well, that's 1. All right. For my second term, what is 2 squared? Well, that's 4. What is 3 squared? Well, that's 9. 4 squared, 16. 5 squared, 25. So in this case, I'm taking whatever my term number is and I'm squaring it. All right, so the way we'll write that is whatever my term number is, my n, and I'll square it. So for example, a sub 1 means in place of n, I'm plugging in a 1. So 1 squared is just 1, which is what my first term should be. All right, a sub 2, I plug in a 2. So that means I'm going to take 2 squared, which is going to be 4. Here's my second term, etc., etc. So 3 squared, 9, 4 squared, 16, etc., etc. So in this case, my particular pattern is a sub n equals n squared. Now, some of these are not very easy to find. Some of them require just some practice plugging in values and seeing what works. Sometimes there's not a rhyme or reason for why any pattern is the way it is. You just have to try things. All right? So let's look at another example. And this will be our last kind of example before we talk about a different type of sequence. All right, so this one's a little more difficult. All right, so I've got 1, 1/3, 1 over 9, 1 over 27. I'm just going to write these down here because it might look a little bit easier. 1/3, 1/9, 1/27, etc., etc. All right, so this one, once again, you're looking to see if you can add anything that's common, if you can subtract anything that's common. We're just going to try and figure it out. All right, so we have a 1, then a 1/3, then a 1/9, then 1/27, etc., etc. Now, if we look at this, all right, I've got a 1, and I've got a 1/3 and 1/9. So we look at my denominators here. So I start with a 3, then a 9, then a 27. Well, I can kind of see a pattern that each of these values in the denominator is divisible by 3. All of my numerators are 1. So right now I can tell you that my equation is going to be 1 over something because all of my numerators are 1. I could even write this as 1 over 1. All right, I can guarantee the next one's going to have a 1, etc. So I can kind of tell that my numerator here, because that's a new 1, 1, 1, 1. So all those have a numerator of 1. All right, let's look at my denominator then. So I've got a 3, a 9, a 27. So 9 is divisible by 3, 27 is divisible by 3. All right, well, 3 to the first power would be 3. 3 squared would be 9. So I'm just going to kind of write that underneath here. 3 cubed would be 27. So I'm just going to write that in here. So notice each of these denominators can be rewritten as 3 raised to some power. If you were to look at the next one, it's probably going to be 1 over 3 to the 4th power, etc., etc. All right, so let's just look to see if it's 1 over 3 to the n power. And again, n represents what term number I'm looking at. So if I wanted to find my first term, it would be 1 over 3 to the first, which would be 1/3. Well, is my first term 1/3? No, my first term is 1, not 1/3. So I've got to do something with my equation then to adjust that. So let's go up here and let's see if we can adjust my equation. All right, so we're going to erase this because that's not what my equation is. So let's see. What if we just did n minus 1 right here? And again, sometimes you just got to play with it and see what works. All right, so let's try this. So now let's try and find my first term. So 1 over 3 raised to the, I'm looking for my first term, my n value is 1, so it'll be 1 minus 1. So it'll be 1 over 3 to the 0. Well, 3 to the 0 is 1. So it'll be 1 over 1, which is 1. So is my first term 1? Yes, it is. All right, so far it's working. So let's look at my second term just to make sure. So this is going to be 1 over 3 raised to the 2 minus 1. So that's 1 over 2 minus 1 is 1. So this is 1 over 3 to the first, which is just 1/3. All right, so far so good. And if you went through, you would see that the rest of these terms match up with their values. So this third term would give you 1/9. The fourth term is 1 over 27. Fifth term is 1 over 3 to the fourth, which is going to be 81, etc., etc. So that is going to be my rule. Again, some of these really don't have a very strong pattern. You just got to, like I said, play with some different numbers and patterns and see what works. All right. So now what we're going to do is we're going to look at a specific type of sequence. All right, and this sequence is called a recursive sequence. And a lot of people get this mixed up and they see a problem like this and they get confused and they flip out because they don't know what to do. You guys have got to know what recursive means. In essence, basically a recursive sequence, all that means is that you're using the previous term or a previous term to find the next term. So for example, you might be using the first term to find the second term, or you might be using the third term to find the fourth term. All right, so recursive means you have to use a previous term to find the next term. Sometimes it's the first, sometimes the second. But the easiest way to go about doing this is just to take and plug in the n value and see what you're using. All right, so for example, this one right here says find the first 5 terms. All right, well, they already give me my first term. You have to have a term with recursive. All right, you have to be given some term with the recursive term. All right, so my first term here, a sub 1, is 3. And remember, anytime you see the a sub 1 or a sub 2, they're giving you a specific term. All right, so they're giving me my first term here. My first term is 3. Now here is my recursive formula. When you see a recursive formula, you're always going to see a sub n minus or n plus. You're going to see something right here, a sub something. That's kind of giving you a heads up saying, hey, this is probably a recursive formula. So let's go through and let's find my second term. Again, the easiest thing here is just to plug in the term number that you're given. So let's find a sub 2. So that means I've got a 2 here. So that means in place of all of my n values, I'm going to go through and plug in a 2. So I'm going to have a sub 2 minus 1 all over. This end of the denominator is also going to be a 2. All right, so let's simplify. So 2 minus 1 is 1. So this is going to be a sub 1 over 2. Now, remember, a sub some number is telling you a specific term. So right here, when this is telling you a sub 1, that's the same thing as telling you your first term. So a sub 1 means your first term. So that means in order to find this, I've got to know what my first term is. So that means in place of that a sub 1, I'm going to plug in my first term. Well, they happen to give me my first term. It's right there. My first term is 3. So in place of a sub 1, I'm going to plug in a 3. So it's 3 over 2, not 3 over 3. 3 over 2, there is my second term. It's 3 over 2. So again, a recursive sequence means you're using a previous term to find the next term. All right, so let's do it. Let's look at another. Let's look at the third term. So to find my third term, that means in place of all of my n values, I'm going to plug in a 3. All right, so everywhere I see an n value up here in my recursive formula, I'll plug in a 3. So 3 here and a 3 here. So this is going to be a sub 3 minus 1 all over 3. So 3 minus 1 is 2, so I've got a sub 2 over 3. Now remember, a sub 2 is telling me to use a specific term. In this case, I've got to use my second term. Well, I just found my second term. My second term is 3 halves, or it's 3 over 2. So it's 3 over 2 divided by 3. All right, so that's going to be my third term. Now I want to simplify that because it's a little bit prettier when you can simplify it. So what I'm going to do is I'm going to make this bottom 3 in the denominator, make that 3 over 1. All right, we've talked about numerous times. Instead of taking a fraction and dividing it by a fraction, let's multiply by the reciprocal. All right, so I've got 3 over 2 times the reciprocal of 3 over 1 is just 1/3. All right, so here my 3's are going to cancel. I'm left with 1/2. Or if you wanted to multiply straight across when you're multiplying your fractions, that's fine. You get 3 over 6, which reduces to 1/2. So there's your third term. All right, so let's find my fourth term. To find my fourth term, anywhere I see an n value, I'm plugging in a 4. So I've got a sub 4 minus 1 over 4. All right, so that's going to give me, when I simplify, a sub 3 over 4. Once again, a sub 3 means I'm using my third term. All right, well, I already know my third term. I found it up here previously. That's 1/2. So this is going to be 1/2 divided by 4. Now, once again, I've got a fraction divided by a number. I'm going to make 4 over 1. So instead of dividing by a fraction, I'm going to multiply by the reciprocal. So the reciprocal of 4 over 1 is 1/4. So I've got 1/2 times 1/4. Let's multiply straight across. 1 times 1 is 1. 2 times 4. That do be 8, yo. There you go. So there's my fourth term. It's 1/8. All right, let's find the last one. Let's find my fifth term. So again, that just means plug in a 5 anywhere you see it in. So it's a sub 5 minus 1 over 5. So 5 minus 1 is 4, so it's going to be a sub 4 over 5. And lastly, guys, one more time, a sub 4 means I'm using my fourth term. So I plug in my fourth term if I know it. Well, hey, I happen to know it. It's 1/8. So we got 1/8 over 5. Now, once again, I'm going to make that 5 over 1. Fraction divided by a fraction. Let's multiply by the reciprocal. So I've got 1/8 times 1/5. So that's going to give me 1/40. There you go. So there's my fifth term. So one more time, just to reiterate, a recursive formula means I am taking a previous term to find the next term. All right, so that's what recursive means. So please, please, please make sure you guys remember that. And if you don't, look back in your notes because they're printed off for you. So please make a note on there about those recursive formulas. All right. So what I want you guys to do is I want you guys to try this next one for me. All right, it is a recursive formula. All right, so I want you guys to try and find your first 5 terms. So go ahead and pause it here and find your next 5 terms. All right. So we've already got my first term. It's 5. All right, so let's go through. Let's find my second term, third term, fourth term, and fifth term. All right, so to find my second term, even if you had no idea that this was a recursive formula, to find your second term, you take a 2 and you plug it in anywhere you see it. So I'm going to take a 2, I'm going to plug it in here, which I've already done, a sub 2, and I'm going to plug it in here. So this is 2 times a sub n minus 1. So I've got 2 times a sub 2 minus 1. All right, well, 2 minus 1 is 1, so this is going to be 2 times a sub 1, which means, one more time, a sub 1 is my first term. So whatever my first term is, I'm going to take it and I'm going to plug it in right there. All right, well, I already know that my first term is 5. So this is going to be 2 times my first term, which is 5. 2 times 5, well, last time I checked, that was 10. All right, cool. All right, so that's my second term. Let's try and find my third term. So it's going to be 2 times. Anywhere I see an n value, I'm plugging in a 3 for my third term. So it's going to be a sub 3 minus 1. Well, 3 minus 1 is 2, so it's going to be 2 times a sub 2. Well, that's my second term. A sub 2 represents my second term, which I already found up here to be 10. So it's going to be 2 times 10, which happens to be 20 or 20. Cool. All right, so let's find my fourth term. So once again, to find my fourth term, I plug in a 4 anywhere I see an n. So it's going to be 2 times a sub 4 minus 1. Well, 4 minus 1 is 3, so it's going to be 2 times a sub 3. Well, that just means I'm using my third term, so it's 2 times my third term. Well, my third term I just found to be 20, so it's 2 times 20, which happens to be 40 or 40. Cool. All right, last one, guys. A sub 5, same thing. Anywhere I see an n value, I'm going to plug in a 5. So it's going to be a sub 5 minus 1, which is going to be 2 times. 5 minus 1 is 4, so 2 times a sub 4. And guys, I can't say it enough. I'm just going to keep telling you. A sub 4 means you are using your fourth term. So it's 2 times your fourth term, which is going to be 2 times 40, which in this case is 80. So there's your fifth term. So again, one more time, recursive formulas are those that use a previous term to find another term. All right, so that's all that we're going to look at for today, guys. Tomorrow we're going to wrap up 11.1. So your homework tonight is right here, page 841, 24, 28, 34, 36, 42, and 44. Now, those are even problems, so you're not going to be able to find your answers in the back. All right, Mrs. Miller can give you guys the answers tomorrow, but I will also go ahead and work out the problems for you and scan those in so you guys can look at worked out problems for those. But that's your homework tonight. Good luck, and I hope you guys are doing well. Miss you guys already, and we will see you guys when I get back.